So calculate the limits of tolerance and allowance for a 25 shaft and hole pair designated by 25H8 and D9. So the very first step is, we know that as 525 it lies in diameter steps. So diameter steps is to be find out from here. So 25 lies in the diameter step of 18 to 30, right? So it lies in the diameter step of 18 to 30 right? Therefore D is equal to under root of 18 into 30, it comes to be 23.2 This is the first step, right? Now we have to find out the fundamental tolerance unit I, which comes in micron. It is given in this design data book. So next step is to find out the values for, or value, not values, value for fundamental tolerance. Tolerance unit, which is given by I is equal to 0.45 third root of D plus 0.001 D, and then put this value into this, it comes to be 0.45 third root of this D 23.2 plus 0.001 into 23.2, it comes to be 1.308. This is in microns. We have to convert this into mm, so it comes to be 0.0013 mm. Okay. Now we know that H8 and D9 is given. So now for H8 hole, we have to find out the fundamental tolerance. So for H8 type of hole, which comes to be IT8, so from this table IT8 is 25I, so that is equal to 25I. We know the value of I, and it comes to be 0.033 mm. This is the tolerance for hole. Okay, hole tolerance. Now for D9 shaft, D9 shaft is given. Now for D9 shaft, we have to find out the fundamental tolerance. So for D9, it comes to be IT9. So from this table, IT9 is 40I. So that is equal to 40I. We know the value of I. So it comes to be 0.052 mm. This is the shaft tolerance, right? Now, as we know from this table, we know that the fundamental tolerance, the fundamental deviation for S type of hole is 0, since this is the 0 line, this is the 0 line, This is the H shaft. Number of shafts are there. This is the lower limit, higher limit will be there. So here the lower limit touches the zero line. So it means that the fundamental deviation in case of S type of hole, it is 0. So that's why the lower limit is equal to the basic size. Okay. This is the zero line or line of basic size. So we know that as the fundamental tolerance, sorry, it's not tolerance, it's deviation for H type of hole is 0. So therefore minimum size of hole, minimum size of hole means lower limit. Lower limit of the hole is equal to basic size, and that comes to be, in this case the basic size is 25. So that is 25, right? Now find out the maximum size of hole. Maximum size of hole is upper limit or high limit, we can say high limit or upper limit or upper limit. That is equal to basic size plus tolerance. Okay, basic size plus tolerance, and that comes to be 25 plus the tolerance for hole is 0.033, that comes to be 25.033 mm. So if we draw the figure, if this is the basic size, this is the hole, this is the tolerance, this is upper limit, this is lower limit. Okay, so lower limit is equal to basic size. Okay, upper limit means maximum size, lower limit means minimum size. Okay, so basic size plus tolerance gives you the upper limit or maximum size of shaft. Now for D type of shaft, for D type of shaft, we have to find out the fundamental deviation. So we are having this table. So if we take the D shaft, so this is the formula for finding out the deviation of D type of shaft. It comes to be minus 16 d to the power 0.44. Okay, because we know that from this figure, these are the various shafts A, B, C, D, E, F, G, H. If you take D type of shaft, it means these are the, it deviates from the zero line. Okay, it deviates from the zero line. This is deviation, then this is upper limit, and somewhere here there is a lower limit. Okay, so this is the fundamental deviation for shaft. So for D type of shaft, the fundamental deviation is equal to minus 16 d to the power 0.44. So So put the value of D, you will get the answer in microns. It comes to be 65 microns. If you put all the values, these are in microns, right? So convert this into mm. So it comes to be minus 0.065 mm. Okay. Now we have to find out the maximum size of shaft. Maximum size of shaft. Maximum size of shaft is equal to basic size plus fundamental deviation. Okay, so the basic size is 25, fundamental deviation is minus 0.065. It comes to be 24.935 mm. Now minimum size of shaft. Minimum size of shaft is equal to maximum size of shaft minus maximum size of shaft minus tolerance. So maximum size of shaft is 25.935 minus tolerance. We have already calculated the tolerance of shaft is 0.052. So minimum size of shaft comes to be 24.83 mm. Now we'll draw the figure. Suppose this is the line of zero line basic size. Okay, so this is the hole, this is the lower limit of hole, that comes to be 25 mm. This is the high limit of hole, or maximum size of hole, it comes to be 25.033. This is the tolerance, it is 0.033 for hole. This is the shaft. Okay, this is the shaft. This is the fundamental deviation for shaft. That comes to be 0.065. Okay, minus, because it is below the zero line. Okay, this is the tolerance for shaft 0.052. This is the maximum size of shaft or high limit of shaft 24.935. This is the low limit of shaft, and that is 24.883. Okay, thank you.